Hi everyone. In this video we are going to talk about and revisit data structures and kind of see where we are in the class. So as a reminder, a data structure is simply just the implementation of how you organize a large amount of data, typically in an abstraction, but it just means in general how you organize the data within the computer. And we talked about these. We've seen this slide a couple times, and comparing, abstraction versus a data structure, and we've been emphasizing it quite a bit. You're really familiar with abstractions now at this point because you've been using them. You're familiar with all the C++ containers, and you really don't yet understand the depths of how those are implemented, but you really understand what behaviors they have. So when you're using an array or a stack, a queue, a set, or a map, you have a pretty deep understanding of what you can expect those types of abstractions to do. And you also have some sense of how they're implemented. We've talked about how you can implement a vector with a C array or with a linked list. We've talked about how stacks and queues could be implemented with decks or linked lists or vectors. There's all these different options. And then with sets and maps, you have this sense that there is a binary tree under the hood, and that's where you get that n log n. And so the data is stored in some sorted order. You also know that there's also hash versions of the set and the map, which have a different implementation behind the scenes that lets it have better efficiency. And so all of these you're already really familiar with. As far as the implementations behind this, you've now seen how to implement a abstraction with a C array under the hood, where all of the memory is allocated sequentially in an order and in one spot. And you've seen how to call new and delete on those types. So we're moving forward and looking at the rest of the data structures, and basically the way you can think of it is the next 4 projects you do are going to do each of these implementations. How much you actually implement is going to vary, but what we're going to be focusing on this week is the linked list implementation. Now, we're going to implement something using a linked structure. And we're doing this primarily because we're going to move into trees next, and trees are tricky. They're more complex than a linked structure that just has a singly linked list or a doubly linked list. And so by first implementing a linked list structure as a class, you will be best prepared to move into our tree implementations. And what you'll notice right away is that implementing a class of some kind with a linked structure versus a C array is very different. And it's very challenging. You have a lot of pointers that are connecting all of your data, and you have to constantly keep them updated. And so while you gain some efficiency in the ability to kind of remove and insert elements into a linked list, you increase the complexity of, you increase the challenge of coding that. You have to draw a lot of things. You have to diagram everything when you're doing linked structures, and that will carry through for everything else that we're doing as well. Then, after we finish this, which we'll be done with about halfway through the semester, we're pretty much spending the rest of the semester on trees and graphs, and then we'll also do hashing as well. So in order to be ready to understand and implement trees and graphs, you have to make sure that the classes that you're writing that use C arrays and that use linked structures are really solid, because all of this builds on each other. So that's kind of where we've been, where we're going. I was talking with someone recently, and we were kind of going back and forth between whether a graph should be labeled as a data structure or an abstraction. So I've added this into all of our notes, that I actually think it could be argued as both, and we'll talk about that when it's there. So if any of you noticed that difference from the last time I showed it, I just wanted to point that out. We'll get to it later though. So we're going to move into link structures. I think writing code with linked structures is inherently very frustrating. I mean, a lot of coding can be, right? But there's a lot more edge cases with link structures than there are with C arrays. And you have to be particularly careful about the front and the back of link structures. And so testing is going to be super crucial for your linked structure classes. So in this week's videos, in the remaining videos, I'm going to go through and build a linkless class for you. It'll be a good example of what this type of class looks like so that you have something to base yours off of. The code is linked in the last slides, so all the code that I go through in the remaining videos you'll have access to, and you can download it and look at it all at once. And what was I going to say? I can't remember. Linkless structure. Basically what I'm going to do is I'm going to go through and build the linkless class one function at a time, or one kind of behavior at a time. And I'm actually going to show it both ways. So I think a lot of you probably already built linkless in your previous classes, but you didn't build them as a class. So I'm going to start by showing you how a linked list just works in general if you just wrote, all your code in main and made up a node struct and whatnot. But then I'm going to show you how that gets converted into a class. One of the things that you probably don't have experience with is managing the memory of a linked list, which is definitely the tricky part of it. So, well, actually it's not the tricky part of it. There's a couple tricky parts of it. But that's something that you'll be able to see in the examples. And so that's what we're going to do this week. And I hope it is helpful as you start building your own linked list class. And yeah, okay, so I think that's it for this one. Yep. So see you guys later.